Chairman Lambourne, members of the subcommittee, thank you for this opportunity to discuss earthquake early warning. The U.S. Geological Survey has worked closely with our state, university, and private sector partners to develop the current pilot system, which holds great promise for protecting
Sir,
lives.
if you could bring the microphone just a little bit closer. Thanks.
Is that better? Yes. Great. So we've worked closely with our state, university, and private sector partners to develop the current pilot system, which holds great promise for protecting lives, livelihood, and prosperity in the future. The earthquake risk in the United States is well known. A single large event could cause thousands of deaths and tens of thousands of injuries from the shaking alone, and much more from possible resulting fires and other hazards. 3/4 of this risk is concentrated on the West Coast, but the impact of a major West Coast earthquake will be felt by the entire country and the rest of the world. A number of military installations, as well as 5 of the 10 busiest ports in the United States, are along the West Coast. The 2 busiest ports are in Southern California, in the heart of the earthquake threat. If those ports suffer significant damage, imports and exports and the businesses that depend on them would be seriously threatened. We at the USGS are proud of our long history of reducing the impacts of earthquakes to the nation by translating our science into practical applications. Our science is used before earthquakes to set insurance rates, develop building codes, and design resilience into critical infrastructure. It's also used after earthquakes to estimate losses and inform emergency response and recovery decisions. Now, the USGS, with our university partners and support from the Gordon and Betty Moore Foundation, have developed a pilot project to demonstrate an important new technology, earthquake early warning, that can detect earthquakes and send alerts so quickly that people and systems can take protective actions before damaging shaking arrives. We call this capability Shake Alert. Earthquake early warning works because earthquake waves travel more slowly than information can be sent out through modern communication systems. It's therefore possible for electronic devices such as smartphones and automated systems to receive an alert that allows an action to avert or minimize damage and injury. Shake Alert is built on the existing earthquake monitoring capabilities of the USGS Advanced National Seismic System. The long-term goal of the project is to issue Shake Alerts wherever the ANSS structure is sufficiently developed. However, the USGS recognizes that the earthquake early warning must compete for finite budget resources, and funding this new effort must compete with existing USGS programs and DOI programs for budget. Recently, we published a technical implementation plan outlining our strategy for moving Shake Alert from a demonstration to full operation and provide alerts to the public and businesses on the West Coast of the United States. The plan calls for adding more sensors, hardening data and alert communications, and rigorously testing the system to ensure its reliability. The plan also lays out how the system would be managed, outlines opportunities for private partnerships, and estimates the cost of building and operating the system. Mr. Chairman, as you noted, several other countries have built systems in response to devastating earthquakes, including the one in Mexico that provided 71 seconds of warning following the magnitude 7.2 earthquake that occurred there this spring. Japan's public system allows every person to receive an advanced alert of earthquake shaking coming from the Japan Meteorological Agency. No trains derailed in the 2011 magnitude 9 earthquake, primarily because of earthquake early warning. A final example, earthquake early warning has also paid off for Japanese businesses. For example, a Japanese computer chip manufacturer suffered $15 million in losses from fire equipment damage and 30 days lost productivity from 2 earthquakes in 2003. The firm then spent $600,000 on earthquake early warning, structural improvements to their business, and the repositioning of sensitive equipment. Since then, 2 earthquakes have struck of nearly the same size, this same area, and have caused just $200,000 in losses and only 8 days lost productivity. You can find further details in my written statement, and so with that, I'll thank you, Mr. Chairman, for the opportunity to provide the subcommittee with the department's views on this subject, and I look forward to answering your questions.
Thank you for your statement, Doctor, and thank you for the good work that you're doing.